Mole is the SI unit to measure the amount of chemical we have. Mole is sometimes makes so much confusion among students as it is just the SI unit to measure atoms or molecules or ions or electrons. Avogadro's number. 1 mole of any substance contains Avogadro's number of particles, which is approximately 6.022 times 1023. Avogadro's number is defined as the number of atoms in 12 grams of pure carbon-12. This means that if you have 6.022 times 1023 atoms of carbon-12, their total mass will be exactly 12 grams. 1 mole of any substance is equal to 6.022 times 1023 object. The object could be atoms, molecules, ions, electrons, depending what we need to find. A mole is a unit of measurement in chemistry used to convert between the mass, grams, of a substance. Molar mass is the bridge between the macroscopic world of moles, 1 mole of a substance, and microscopic world of atomic mass, grams, of an element. Just like any bridge connects two different places together over an obstacle like a river or valley. We need this because atoms are extremely small and impossible to count. As it is not visible, it makes even harder for us to picture the concept mostly. We know that the base SI units are meter, m for length, kilogram, kg for mass, second, s for time, mole, mol for the amount of substance. The mole isn't any different but an unit of substance measurement. Why SI unit is needed? The International System of Units, SI, is needed to provide a universal, standardized, and consistent system of measurement for global communication, accuracy, and simplicity in science, industry, and daily life, so everyone in the world can stay on the same page. Atoms or molecules or ions, they are extremely small. Counting them individually is impractical, so a unit is needed to represent a manageable, macroscopic. A mole is a unit of measurement, represented by the symbol mol, that signifies a quantity of a substance. Specifically, 1 mole contains 6.022 times 1023 particles, such as atoms, molecules, or ions, of that substance, a number known as Avogadro's number. It's a convenient way to count the incredibly large numbers of tiny particles in chemical substances. What is Avogadro's number? Amedeo Avogadro proposed a number for particles in a mole of a substance because it helps bridge the gap between the microscopic world of atoms and molecules and the macroscopic scale of everyday measurements, a discovery that was foundational to the concept of the mole and Avogadro's number. In 1811, Avogadro published his hypothesis that equal volumes of all gases at the same temperature and pressure contain equal numbers of particles. Avogadro's hypothesis was not agreed upon when he proposed it in 1811. It was largely ignored and even rejected by contemporaries like John Dalton, due to many scientists could not distinguish between atoms and molecules, making it difficult to accept that equal volumes of gases could contain equal numbers of molecules. Century later, Jean-Baptiste Perrin, 1909, made an experimental estimate of Avogadro's number based on Einstein's theories on Brownian motion. Perrin was the first to use the term Avogadro's number and was recognized for his work. Avogadro's number is named after Amedeo Avogadro to honor his 1811 hypothesis that equal volumes of different gases at the same temperature and pressure contain the same number of molecules. Avogadro's number is a fundamental constant equal to 6.012 x 10^23 and represents the number of atoms, molecules, or other elementary entities in 1 mole of a substance. A link between mass and number of particles. The mole concept allows chemists to convert between the mass of a substance, in grams, and the number of its constituent particles. Why carbon was chosen for the mole? The number 6.022 times 10^23 is chosen for the mole because it is defined as the number of atoms present in exactly 12 grams of the carbon-12 isotope, establishing a practical relationship between atomic mass units and grams. In order to understand mole concepts clearly, we need to review what is atomic number and atomic mass of an element. Atomic number, the number of protons within the nucleus of each atom of that element, is the atomic number of that element. If you have hard time remembering that, remember proton end with N. Atomic number starts with N, so atomic number is the number of proton. For instance, hydrogen, atomic number 1, has 1 proton, while helium, atomic number 2, has 2 protons. Hydrogen, atomic number 1, helium, atomic number 2. Atomic mass is the mass of a single atom. The atomic mass mostly comes from the combined mass of the protons and neutrons in the nucleus, with minor contributions from the electrons and nuclear binding energy. What is molar mass m? Molar mass is the mass of 1 mole, a specific quantity of a substance, typically expressed in grams per mole. How to find it? Choose the element the question asking for molar mass. Look the name of element in the periodic table. Whatever atomic mass below their symbol, if it is only one atom of the molecule, then we don't have to multiply or add. We just add the unit gram per mole. This is it. This is the molar mass of the element, if there is 2 atoms in a molecule. Like the molar mass of O2 is approximately 32.00 grams per mole. This is calculated by multiplying the atomic mass of a single oxygen atom, around 16.1 amu, by 2, because the O2 molecule consists of 2 oxygen molecules. The molar mass of NaSal, sodium chloride, is approximately 58.44 gram per mole. This is calculated by adding the molar mass of sodium, which is about 22.99 gram per mole, and the molar mass of chlorine, Cl, which is about 35.45 gram per mole. You can solve any problems with one single formula by flipping it with given values. Molar mass equal to gram per mole. To remember it, use the sentence Mr. Molar. Go straight to the massive garden, look down and see moo moo cow. Mr. Molar is the molar. Go straight means opposite side. Massive garden. Massive represents mass of a substance. Look down means divided by, and see moo moo cow. Moo moo means mole. If you have a good memorization skill, you don't need the sentence to remember the molar mass formula. The students who struggle to memorize formula, it will be useful for them. This formula you can flip and change so many ways, and that's how you can solve the practice problems given in the school. You can write this way too. Formula: moles equal to mass, gram, divided by molar mass, gram per mole. Or mass, gram, equal to moles, mole, times molar mass, gram per mole. Mole is sometimes written as mole. It's one main formula. You can use so many ways. Stoichiometry depends on the mole concept. What is stoichiometry? It sounds Lord of the Ring dark magic or something. Good news, no. It's a real-world thing in chemistry territory. In chemistry, stoichiometry is the calculation of the relative amounts of reactants and products in a chemical reaction, using balanced chemical equations to determine how much of one substance is needed or formed from another. It acts like a recipe, where the coefficients in a balanced equation provide the mole ratios, allowing chemists to calculate specific quantities of substances. In chemical reactions, the coefficients in a balanced equation represent the number of moles of reactants and products. The mole concept enables chemists to calculate the precise amounts of substances needed or produced in a reaction, ensuring correct proportions. It's like if you are making 1 cup of coffee, you need 1 teaspoon sugar and 1 tablespoon creamer. You can't add 5 tablespoons creamer and 5 tablespoons sugar in 1 cup of coffee. It won't coffee anymore. Or think about any dessert you like, it'd have to follow a recipe with how much of what ingredients. This is how cooking is so much fun to some people. Very few doesn't like it to cook by themselves. Ingredients are the items you combine, like flour, sugar, and eggs. Reactants are the substances you start with in a chemical reaction. Finished dish is the final product you want to eat, such as pancakes or a cake. Products are the new substances created by the chemical reaction. Scaling a recipe involves multiplying all ingredients by the same number to make more or less of the finished dish. Stoichiometric calculations allow chemists to determine how much of a reactant is needed to produce a certain amount of product, or vice versa, based on the ratios in the balanced equation. The instructions tell you the proportions, for example, 1 cup of mix and 1 egg for every 8 pancakes. A balanced chemical equation uses coefficients, numbers in front of each molecule, to show the exact proportions of reactants needed to produce a specific amount of product. The big difference. We just used cooking recipes as an example of understanding stoichiometry, where both of them are different in so many ways. In chemical reactions, one mistake or little bit of change in chemical can cause huge differences and problems if not followed properly. With a cooking recipe, you can sometimes get away with minor changes to the ingredients and still get a recognizable, if slightly different, result. In stoichiometry, the ratios are not flexible. Atoms must be conserved, so the proportions are strict and non-negotiable. By understanding mole and stoichiometry, we can understand chemistry clearly and there is no guessing and frustration. By using mole, chemists can convert between mass, moles, and number of particles, allowing for precise calculations in various chemical contexts. Understanding moles is the pass of chemistry world entry. We have to have it to explore chemistry, and we got it.